All right, so let's just recap the things that we have already learned about the Pythagorean theorem. Okay, so we know in a right triangle, a squared plus b squared equals c squared. Of course, okay, so that we've learned that's old news. So I can use the Pythagorean theorem to, if I know I have a right triangle, I can use it to solve for any of the missing sides, whether it's the hypotenuse or one of the legs. Okay, so that's fine. We did that. Then we also did the other way around. We also learned that if a triangle's three sides fit a squared plus b squared equals c squared, then we know it's a right triangle. Okay, so those were lessons that we did, I don't know, last week, 2 weeks ago. So remember that we took three sides of a triangle and we're like, okay, let's test this and see if it really is a right triangle or not. And sometimes it worked. Sometimes a squared plus b squared really was c squared. And then I knew I had a right triangle. So did you know that you can use Pythagorean theorem to not only determine if you have a right triangle, but based on how the answer comes out to a squared plus b squared, whether it's obviously if it's equal to c squared, it's a right triangle. But if it's not equal, I can actually use the answer to tell me if I'm going to have an acute triangle or an obtuse triangle. What? Yes, it's so cool. So watch this. So, let's just make a little chart here. A squared plus b squared equals c squared. That's a right triangle. So let's say is a right triangle. But now watch this. If it turns out that a squared plus b squared is less than c squared, this type of triangle is an obtuse triangle. So you're still going to do the math the same way. You're still going to take A and B, put them in, square them, add them together. C is still always going to be the longest side. So just make sure that you put in the longest side for C. And then when I get it, we'll do a bunch, obviously, but now I can just compare the two values. So if a squared plus b squared is less than c squared, it's a right triangle. Or sorry, I was looking at the word right. An obtuse triangle. So naturally, if you go the other way around, if a squared plus b squared is actually greater than c squared, now you know you have an acute triangle. How about that? So let's go ahead and test this. Let's take a triangle that we know is acute. So for example, an equilateral triangle, right? Those, I know the angles are 60, 60, and 60. So I know that it's got to be acute. So let's see if it really does work. Okay, so let's do examples. Let's give some overall directions. Determine if each triangle is right, obtuse, or acute. So there's our three choices. Okay, and let's see what happens here. So I said, why don't we go ahead and start off with one that we know. So I know that if I have an equilateral triangle, all the angles are going to be 60, so it should come out to be acute. So let's just say we took 5, 5, 5. So I already know this should be an acute triangle, but let's actually plug it in and see what happens. So I'm going to do a squared plus b squared, and I'm going to figure out how it compares to c squared. All right. Now, since all of them are the same, it doesn't matter who you call a, b, and c, right? Obviously. So I'm just going to do 5 squared plus 5 squared. How does that compare to 5 squared? So 25 plus 25, how does that compare to 25? I'd get 50 is obviously greater than 25. So as you can see, if a squared plus b squared is greater than 25, I should be having an acute triangle, and I know that I do for this one. So I already knew that it was going to come out that way, and it did. So that's pretty cool. Let's try another one. What if you had sides of, oh, I don't know, how about 7, 8, and 14? How will this come out? So I'm going to sort of start off by operating in the same way. I'm going to test, how does a squared plus b squared, how does it compare to c squared? All right, so now here I have different values, so it does kind of matter who goes in for what. Just remember that I do need to put in the biggest number for C. So in this case, it's got to be 14. So that one just has to go in for C. They're not necessarily always going to give you the numbers in order, though. So be careful. Just make sure that the biggest one is going in for C. So I'm going to do 7 squared plus 8 squared. And we're going to see how that matches up with 14 squared. All right, so let's see. 7 squared is 49. 8 squared is 64. How does that match up with 14 squared is 196? All right, 49 and 64 just so happens to be 113. So 113 is definitely less than 196. So can anybody tell me what type of triangle this must be? Let me zoom out a little bit so you can get them all in there.
Acute.
Be careful.
Obtuse?
Yeah, right? Because isn't a squared plus b squared is less than c squared.
Oh yeah, Maddie.
So I want that one. This would have to be an obtuse triangle. Oh, and I never even wrote the answer on the first one. Sorry. So obtuse is my answer. Make sure that you add back on this one. We should have written down that it was acute. How interesting. All right, let's try another one. So for example 3, let's try, oh, I don't know. How about 10, 24, 26? I'm going to give you all a moment to try this one. Okay, does anybody have an answer for this one? So remember what I'm looking for. I'm looking for, is your triangle going to be right, obtuse, or acute? So you're using the Pythagorean theorem to determine it. So you're going to plug your numbers in and see which of these three scenarios comes out. You're always going to get one of the three. So if it's equal, it's right. If this side is less than this side, then you know you have obtuse. And if it's the other way around, if this side is greater, you're going to get acute. So with 10, 24, 26, did anybody get an answer? So remember, you got to test a squared plus b squared. How does it compare to c squared? Oh, I got one answer, and it's a correct answer. And the correct answer is right. Ha! So let's look. Again, make sure, just do a quick check and make sure that your biggest number, which in this case is 26, is going in for C. So I need to check 10 squared plus 24 squared. How does that compare to 26 squared? Well, I don't know yet. Let's find out. 10 squared is 100. 24 squared, I don't know that one. 24 squared is 576. And how does that compare to 26 squared, which is 676? Oh, hey, how about that? This time I get 676 equals 676. So when that happens, if both sides are the same, that means I have a right triangle. So that's my answer this time. This has to be a right triangle. All right, let's try one more. Well, that's a lie. We're going to try a bunch more. But one more on this page. How about, oh, I don't know. How about 3, 7, and I don't know, 9.
Please pardon the interruption. At this time, group 7, grade 11, comma to right. Please report to the auditorium for pictures with Les Gardner. Again, group 7, grade 11, comma to right. Please report to the auditorium.
Feel free to send me your answers in the chat. Elizabeth, I believe you're correct. So Haley, your numbers are right, but that's, if that's what is coming out, that's not, it doesn't mean what you're saying it means. Yes, right. Okay, so I've got a couple of answers here. So, oh, okay. I'm gonna give you another minute. Oh, and I meant to do something to this one, but I forgot. I'll do it on the next one, but I won't tell you what it is. Olivia, that's right. Now, what does that mean? Which type do you have? It's only going to be right if they're equal to each other. I think you got to look back at this. There we go. So if your right-hand side, your c squared, if that's the big one, right? Which I think is what's coming out on this, then it's going to be obtuse. Yeah. So let's see how this works out, because this is another one of those. Oh shoot, my stupid camera froze. Oh, this thing's so frustrating. Sorry, let me just reset it. Oh, come on. Why is it still stuck? Oh my gosh, this stupid thing. Oh, wait, there we go. Oh, for the love. Okay, so anyway, yes, we're here. So remember what we're doing. We got to pop in a squared plus b squared, and let's see how it compares to c squared. So I'm going to get 3 squared, 7 squared, 9 squared over here. So that's just 9, 49, 81. 9 and 49 is 58. And 58 is definitely going to be less than 81. So if I go back up to that listing, and the c squared is the biggest thing. So this over here is the biggest chunk. If I scroll back up here, where we wrote all this stuff down, when c squared is the biggest, like it is right here, that means I have an obtuse triangle. Okay, so let's write down that this thing was obtuse. And that's how that works, okay? So you pop the 3 in. If it's equal, you know it's right. Like it happened over here. So that's easy. And then if it's not equal, though, you have to go back and just compare. Or I kind of have a way to remember this. I don't know if this helps you or not, but I'll show you on the next page. So the way that I remember that this comes out as obtuse, a squared plus b squared, I think about this as having a big old c squared, right? And c is the hypotenuse. So if I imagine a triangle that just has this big old c squared, right? Big old third side. And then the other 2 sides are smaller, right? So just look at what kind of a triangle this ends up looking like. Let's see. See, when you have one side that's really big like that, you end up with an obtuse triangle, because it's, if this side's so big, that means that this angle's got to be big. So that's something that I used to help myself remember, but you guys have open notes, right? So as long as you actually take the notes down, then you don't really have to remember any of it. You just have to be able to, you know, locate it in your notes and know how to decipher it. So yes, that leads me to an obtuse triangle. If I don't have a big old c squared and everything's just kind of little, there's my acute. And then of course, you know, when it's equal, it's right. So I'll just have this on this page. So we have it conveniently here for us to see as well, even though I know you just wrote this down on the other side, but just in case you missed it. All right. So let's go ahead and try some more. So this will be example 5. Let's do 10, 9, 7. Hold on. We already, no, we didn't do that yet. Okay, 10, 9, 7, just like that. I'll give you a hint on this one. I am trying to trick you. Don't fall into my devil's snare here. Ooh, who did I? Olivia, I got you in this trap. Be careful. So the trap, I'll give you a hint. Make sure. Okay, I'll just tell you. It's not really a hint. You got to put the right number in for C. Be careful. Who's C this time? It's not always just the last number. It's the the biggest number has to go in for C. So you can't bank on it always being given in the right order. Yes, yes. Still, again, A and B don't matter because you're adding them. You just have to make certain that you put C in where C goes. So Haley, I think you got caught in my trap also. You might end up, I think your final answer happens to be right, but I think you just got lucky there. So everybody, please watch. When you do this, you have to do it like this. A squared plus B squared. How are we comparing to C squared? These two are A and B, 9 and 7. C is 10. So that one's got to go over on the other side, right? So here, I'll even call, there's A, there's B. You got to be careful. The biggest number in your list has to go in for C. And then A and B, those ones you can sort of switch around. But you have to take the time and make sure that the biggest number is being put in for C. Let's see. 9 squared is 81. 7 squared is 49. How does that compare to 100? 81 and 49 is what, 130? 130 is greater than 100. So if you look back up, look at our little handy dandy chart we just rewrote right at the top. If A squared plus B squared is greater than C squared, what do I have? Is it obtuse, acute, or right? It's acute, yes. So if I match it up, right? Look at my arrow. My arrow matches with this one, so it's acute. That's your answer on this one. Okay, I'm gonna do 2 more, and then I will let you guys go on to your homework. So let's try, how about, let's do 15, 25, 20. All right, everybody try that one. Let's see if I can get the handy dandy little chart on here at the same time, but you should have it written down anyway. But just in case you don't, there we go. And let me cover this so you can see it more clearly if that helps. I'm always battling the sun here. Ah! Trying to figure out where I can. Well, this just makes it worse. I'm trying. See, like on my computer screen, the image is always really clear. But then when I look on my Chromebook, like it's super fuzzy. So I'm imagining that if mine's fuzzy, then it's probably fuzzy on your end too. especially if you're using something like a Chromebook. All right, so I'm going to zoom in so you can see these. All right, so you should have your chart already. All right, so I have one answer in the chat for 15, 25, 20. Anybody else want to put in an answer before we try it? Okay, I'll give you another minute. Oh, I got another answer. That's correct. Don't fall into my trap. I set one. Oh, I was waiting for you to give me your answer. I thought you wanted to do it. Yeah, so the answer here is right. This should be a right triangle. Be careful. Make sure you're putting 25 in for C. That's the biggest one. So you got to do something like 15 squared plus 20 squared and see how that compares to 25 squared. So just make sure you've got 25 over here on the side. And now we're going to do the math. So 15 squared is 225. 20 squared is 400. How does that compare? 25 squared is 625. Oh, lo and behold, 225 and 400 is 625. So when they're equal, remember that just means that, yep, this is in fact a right triangle. By the way, this was a Pythagorean triple. This was a 3, 4, 5. I just multiplied them all by 4. Don't forget about those. Those can save you some time. So if you happen to recognize, oh, hey, look, I could divide all of these by 5 and I get, that would be the 3, 5, and this one ends up being 4. But there's your 3, 4, 5. And you know 3, 4, 5 is the right triangles. So if you see them, can save you a little bit of time. All right, I want to do one more, and then I will have you guys do your homework. Okay, we're looking good on time too. All right, so last one, let's do 4, 8, and 11. Oh, I'm sorry, Olivia. I misread your thing. You said you can see the answer, but I didn't have an answer written down yet. I thought you said, I read it as, can we see the answer? And then I was like, oh yeah, of course let's do it. I didn't have an answer written down yet though. For the last one. Oh, unless you were looking at, oh, Haley's. Got it.
Yeah, I didn't realize that I accidentally sent it to everyone, and then Olivia was like, you can see it. I was like, well, you're welcome, everyone.
Oh, got it. Oh, I'm so confused.
Mobby.
So now all of you try this one. Elizabeth, that's right. Olivia, that's right. Haley, that's right. Okay, good. So again, figure out who C is. This time I left them in order. So now we know, okay, 11's going to go in for C. So I'll just check 4 squared plus 8 squared. And how does that compare to 11 squared? I've got 16. I've got 64. And 11 squared is 121. So if I add 16 and 64, that's what, 80? 80 is less than 121. So when I have this big old C squared, remember if you go all the way back up to our little chart here, woo, there we go. So when C squared is the biggest thing, I have an obtuse triangle. So getting this number, you know, this comparison of numbers is great, but you need to be able to tell me now, well, what kind of triangle is it? So an obtuse triangle is what we have here. And we are done. Okay, so your homework this evening is going to be on, it's CUDA again. I think this whole week is CUDA, honestly. So let me go make it live for you. I will also do out 1 or 2 of them if anybody wants me to, but if you feel like you're ready, then you can go for it. Just give me a second to activate it. Yeah, so on, yeah, all right, let me just make it live and then I'll show you. Okay, so it should be live for you now. I'm going to do 1 or 2 just for the video. And if any of you need additional help. So let's go ahead and share this. All right, so your first section is going to be questions just like this. And so same thing, they're just drawing a triangle for you. I didn't draw the triangle for you, but whatever, you don't need it. So anyway, let's see, you're just going to make sure that you put in, look at your 3 sides, 9, 12, and 19, and make sure whichever is the biggest side you're putting in for C. So that one's got to go in for C. The other 2, it doesn't matter. So pick one to be A, pick the other one to be B, who cares? So now you're going to do your test. You're going to check how, well, actually, let's write it over here. If A squared plus B squared is equal to C squared, you know that's a right triangle. If A squared plus B squared is less than C squared, that comes out as obtuse. And the other way around is obviously acute. So we'll have this handy dandy list right here for easy reference. That's acute. All right, so now I'm going to do it. I'm going to check A squared. So that's 9 squared plus B squared is 12 squared. How does that compare to C squared, which is 19? So I just do the numbers, 81, 144, I don't know, 19 squared, 361. 81 and 144 added together is 225. So 225 is less than 361. So now you need to look at our handy dandy little chart up here and figure out, do I have right, obtuse, or acute? Which of the 3 is it? And all I really do is I just match up my inequality symbols. So I'm looking right here. I'm looking at this symbol and I say, oh, it matches this one, so it's got to be obtuse. That's really all there is to it. So this has got to be choice A is my answer on this one. All right, so we're really just looking at that. So I'll do one more of this type. So let me erase all of this. See if I can erase these highlights that I drew. Oh. Head back in there. Didn't mean to erase that. All right, let's try the next one. Oh, I didn't erase everything. Silly goose. There we go. All right, the next problem. Here it is. So all I need to do is make sure that I'm putting in 10, the biggest one, for C. I already know the answer to this one because I recognize something about this one. So if you recognize something about this one too, great. If you don't, that's fine. Then just put them all in. Just make sure you're putting 10 in for C. And then the other two really don't matter. I'll call you A, I'll call you B. So I'm just going to check. How does 6 squared plus 8 squared, how does that compare to 10 squared? So 6 squared is 36, 8 squared is 64. How does that compare to 100? Well, 36 and 64 is 100. So it turns out they're equal. So if it's equal, I know I have a right triangle. And the reason why I knew this answer so quickly was because I noticed 6, 8, 10, that's a 3, 4, 5, just doubled. See, I wasn't kidding when I told you 3, 4, 5s are everywhere. They pop up a lot. So the more familiar you are with them and the I don't know, if you recognize them, it just saves you a whole bunch of work. Because they're always right triangles, 3, 4, 5s. All right, let's do, I want to do one of the next type. But it's pretty much the same thing. I just don't give you a triangle. I just list it in, just give you the listing of the 3 sides. So let me scurry to the end. Yeah, like these. So I'm just listing it out for you. That's all. So, but I operate the same way. Make sure that you put in whatever is the longest side goes in for C. So I'm checking 6 squared plus 8 squared. How will that compare to 13 squared? Well, I don't know. 36, 64. How does that compare to 13 squared is 169? 36 and 64 is 100 when you add them together. 100 is less than 169. So now I'm like, okay, well, it certainly isn't a right triangle. So now I'm coming in and I'm matching up my symbols here. So I'm looking at this symbol and I'm like, okay, that matches this one right here. So I must have obtuse. Choice B. Okay, so that's how this works. Does anybody have any questions right now? None right now? Okay, so I'm going to stop the video here.